was a time when all you needed to work in a technical career was to be handy with machines. But just being handy is not enough anymore. In the world of modern technology, machines are becoming faster, more talented, and even smarter. Anyone who wants to work with modern devices needs to know the basic principles behind those machines. More and more, technicians from different backgrounds are having to work together because they find that their fields are crossing in modern machines. So the mechanic is now talking to the electronics expert. The hydraulics expert works alongside the heating expert, and so on. Even a specialist in one field has to know something about other fields to work with today's complex technology. Look in any newspaper and see the qualifications for technical careers. Employers are looking for people with a broader base of technical qualifications. Principles of Technology is for anyone who's interested in this world of complicated technology or who wants to work there, like Darren Grant.
That's my last job of flipping hamburgers. I want to get a good job in a technical field, but where do I start? There's this new course being offered at school, but I don't know. I'm really glad my friend Larry's taking the time to give me some advice. Hi Larry, how you doing?
Oh, hi Darren.
Did you get that book I sent to you on Principles of Technology?
Yes, I did.
Oh, that's good.
I've got it right here.
My teacher's, pretty hot on it and he advises that I take this course.
I got it.
People in the technical workplace know the value of Principles of Technology.
Good basics. You're still
These are your future employers. And if you come to them with a basic knowledge of how things work, you will be farther ahead than someone who is starting from zero.
taking this course.
Technology is constantly changing, so there will always be further specific training on the job. But if a person like Darren starts with an understanding of basic principles, he will have a head start when facing those changes.
Over the years, typewriters have evolved from a purely mechanical device to electromechanical and now electronic device. The training and education that a person needs to keep up with that has to keep evolving.
So what is Principles of Technology? It's a course in applied science that provides an understanding of the basic principles behind technology. Most of the principles appear in a wide variety of systems. There's a term we're going to be using a lot, systems, so let's define it here. A system is anything from a bicycle to a bulldozer. It's a collection of moving parts working together to do a specific job. Systems can be a very complex arrangement of parts, but there can also be smaller arrangements of parts within it, systems within systems, or subsystems. But machines are nothing more than nuts and bolts, so there's another meaning to the word system: energy systems. Energy systems are what cause the nuts and bolts to move. Forces, prime movers, resistance to movement, all govern what happens, how fast, and when. It's the scientific principles behind the energy systems that you will investigate in Principles of Technology. Understanding these principles can give you the tools to carry you into the technological future. We will look at only 4 energy systems throughout the course: mechanical systems, which move objects; fluid systems, which move liquids and gases; electrical systems, which move electric charge; and thermal systems, which move heat. These are 4 important systems we will be dealing with, because one or all of them will appear in virtually every form of technology. More important, There are similarities among the principles in the different systems. For example, voltage in an electrical system and pressure in a fluid system act in a similar way, even though one involves electricity and the other involves liquids and gases. We will show these similarities so they can be compared, making it easier to understand. We will make these comparisons and find similarities for every topic in the course. In the first year, we will look at force, work, rate, resistance, energy, power, and force transformers. If you choose to continue with year 2, you will look at momentum, waves and vibrations, energy converters, transducers, radiation, optical systems, and time constants. In every case, we will see how these principles operate in mechanical, fluid, electrical, and thermal systems. How do we plan to do that? Basically, principles of technology is divided into 2 parts, things that we do for you and things that you do for you. We do the videos, lead class discussions, and do demonstrations in the classroom. You practice using the principles in math labs, hands-on labs, and do some background reading. We've produced 6 video programs for each of the 14 topics. That's 78 programs, so you should get pretty used to the sound of my voice. We will be taking our cameras into places where you may find yourself working in the future. Some of the technology might be familiar, and some of it not. We will also be taking you to places that you may think have nothing to do with technology, but they actually demonstrate the same principles.
That moved over that period of time.
We will also try to use some of the magic tools of television animation to take you inside the technology and demonstrate the principles that make it operate. You will meet real people who need to know the principles behind their technology in order to do a good job.
One interesting point to remember about a coal-fired generating station such as this is that we don't really create any energy at all. We really take one form of energy, potential chemical energy in the form of coal, and convert that to a more useful form, electrical energy, that's more helpful to the consumer at home.
The fluid resistance helps us in turning the turbine blades, turning the turbine along the shaft, but we encounter mechanical resistance in that the shaft is resting on metal bearings.
After we have replaced the spark plugs and these kind of things, and it didn't work, then we're going to have to go on to further things. We're going to have to take a compression check to find out if there's any mechanical problems within.
Once you've seen our programs, you will be holding discussions in your class. 10,000 tons of snow careening down a mountain. You will talk about events that you've seen in the programs and how they relate to your studies. We invite you to get involved in these discussions.
A pile driver is a good form of potential and kinetic energy.
Your teachers will have their ideas to share with you.
Snow and ice was the same as you saw in the avalanche.
And occasionally, they may even have a few tricks of their own.
Yesterday, I remembered that we had a film, and I thought we would ask a couple of questions about it. Do you remember what was on the film? Mary, what was on the film yesterday?
Wrecking balls.
Wrecking balls. And remember, well, that's a good idea. It leads us into our little demonstration for today. Anything else? The avalanche. And these 2 ideas of the wrecking ball and the avalanche both have to do with energy, don't they? And we do know that there's 2 types of energy, potential energy and kinetic energy, isn't there? Right. Okay. Let's see if we can find a quick demonstration to prove whether the kinetic energy and potential energy are basically equal. John? Right over here. Let's see if we can get a demonstration going here. Now, if this is right, kneel right down there, and we'll put this right by your nose. See, John? And if it misses your nose on the way back, then we're all right. Okay. You better get a little lower here, because I don't want to have you pick up yourself out of the wall there, you know. Okay, here it goes. Here it goes. Everybody's ready? Oh, John! All right, John! I didn't move. John didn't move. That's a good demonstration, John.
If you survive the demonstrations, it's your turn. You will then have the opportunity to try these principles out for yourself, and you'll do that in two ways. The first is to practice some of the mathematical relationships and see how they work on paper. To be in control of these relationships, you need to predict what effect one event will have on another. It will also help you find out what went wrong when an event doesn't happen. We will show you some simple formulas like this one from our rate program. Suppose you want to calculate an acceleration. What you are measuring is how much the rate changes over a period of time. So what you need to know is the difference between the speed at the beginning and the end of the change. So take the speed at the end of the acceleration, or the final speed, and subtract from that the speed you began with, or the initial speed. Divide all of that by elapsed time. What you end up with is a rate over time. You will then have a chance to see these principles in action for yourself. Using your own laboratory equipment, you'll be able to measure effects, experiment, calculate, and predict results in a hands-on environment. The last element is your own reading. We are only giving you the bare bones. You can find out how these principles operate in other areas of technology. These elements, the video, class discussions, teacher demonstrations, math skills labs, hands-on labs, and your own reading will provide you with an exciting and interesting look into the world of technology and the principles behind it. Technology comes in many forms and changes from year to year, but the principles behind that technology have been true for hundreds of years and are still true today. If you understand the principles today, you will be better prepared to meet the changes that tomorrow's technology will bring. After all, you never know where these principles will show up.